Hello once again, class, and welcome to another mock lecture. Today we're going to be talking about polynomial division, and I thought a good place to start would be with long division. So here we're trying to divide 175 by the number 3. And to just refresh your memory, the way that this works is you first try to figure out how many times does 3 go into the number 1, which of course it doesn't. So then you move to 17 and you say, well, how many times does 3 go into 17? And it goes in 5 times. You then do this really weird subtraction where you're taking 17 and you're subtracting away the multiplication between the part of the answer that we just found multiplied by the thing we're dividing by, the 3. The reason I say it's weird, by the way, is because normally when you're doing subtraction, you don't line things up like that. Usually you line them in terms of like we're doing the ones position, then you do the tens position, then you do the hundreds position. But here it's aligned all weird, right? You're doing this. Anyway, so 17 minus 15 is 2. And then you carry down the 5, and then you got to try to figure out how many times 3 goes into 25. By the way, this weird subtraction that I mentioned before can actually be really easily explained because what's actually happening is you're doing 175 minus 150. We're kind of breaking up the way that we do this division. And initially we're saying, hey, 3 goes into 175 50 times, right? We're just trying to get the tens position first, and it goes in 50 times. And then we'll worry about the ones position second. And that's why we take it in pieces like this. Anyway, 3 goes into 25 8 times. And then you subtract away the multiplication of 8 and 3, which is 24. So you get this, which is called your remainder. And that's it. Now, all these other things have names as well. The thing that you're dividing by, that's called your divisor. The thing that you're dividing, that's called the dividend, and the answer that you get, kind of in conjunction with the remainder, is called your quotient. And these 4 things comprise what is known as the division algorithm, which says that a number, a dividend, is equal to a quotient times some divisor plus a remainder. And so we just found out that 175 is equal to 3 times 58, which is 174, plus 1. Okay, now you might be asking, well, how does this apply to polynomials? What is the point of refreshing our memory on this? Well, actually, polynomials are almost exactly the same insofar as division. The only thing that's different is when you divide by a monomial, which is a single term. Anytime you have something like this, just immediately apply that denominator to all pieces of your numerator and then simplify them. 5x cubed divided by 5x squared, the 5's cancel, x cubed divided by x squared, that's just x. 2x squared divided by 5x squared, that's just 2/5. And then these don't actually simplify at all. So I guess technically you could say, well, that's actually divisible by 5, so you could make that a little bit easier. But instead, I just wrote them as one thing over our divisor. So if you have a monomial that you're dividing by, that's what you should do. It's when you're dividing a polynomial by not a monomial, right? So like here, we're dividing it by a binomial. X minus 3 is what our denominator is. So here's how we're going to do this. First, we're going to rewrite it so that it looks very similar to long division. And then we're going to play exactly the same game that we did with long division. We need to figure out how many times does x go into 2x cubed. That's at least conceptually what we're answering. I actually don't ask myself that question though. What I ask myself is what do I need to multiply x by in order to make it look like 2x cubed? Because for me, that's an easier question to answer. So I think about it in terms of almost like multiplication. Find the missing part of the product that gives us 2x cubed, and that's going to be 2x squared. Okay, I like to align things over the correct power. So since we have to multiply x minus 3 by 2x squared to make that leading term 2x cubed, that's what I'll write above the x squared position. Then we're going to subtract away something. And what we're going to subtract away is the part of the quotient that we just found multiplied by the entire divisor. So you'll notice actually, if I go back to here, I'm not asking myself, how do I make x minus 3 look like 2x cubed? I'm just asking myself, how do I make x, the leading term of my divisor, look like 2x cubed, the leading term of the dividend? But when I do the multiplication part to subtract something away, now I have to multiply 2x squared by that entire divisor. And so what I do is I put a minus sign here, and then I open up a set of parentheses, and then inside of there, I'm going to actually put the multiplication of the part of the product that we just found multiplied by the divisor, which gives me 2x cubed minus 6x squared. And you'll notice I kind of jumped the gun a little bit on this slide. When I'm doing the subtraction, 2x cubed minus 2x cubed, those cancel. But then the reason that I like to do minus and then open a set of parentheses is because when I'm reading how to do this subtraction, I see that I'm doing negative 3x squared minus negative 6x squared, so this becomes positive. So I ended up with positive 3x squared there. And then I bring down the minus 11x. And that's it. That's all you do. You just do that until you can't do it anymore, and then that's whatever you have left is your remainder. But that's basically the idea for polynomial division. So to keep going, we need to make x look like 3x squared. To do that, I'm going to multiply x by 3x. So I put the 3x here, then I multiply the part of the quotient that we just found by the divisor, right, which is x minus 3, and I'm subtracting that away. That's what's going to go inside the parentheses here. Now we do 3x squared minus 3x squared, so those cancel, and then you have negative 11x minus negative 9x, which is actually going to be an addition, so we'll have minus 2x there. And then we'll bring down the 7. Now how do we make x look like negative 2x? Well, we multiply by negative 2. So then we multiply the part of the quotient that we just found, negative 2, by the divisor, x minus 3. We stick that in the parentheses here, and then we read this off as negative 2x minus negative 2x, which this becomes positive. So we have negative 2x plus 2x, so those cancel. And then 7 minus 6 is 1, and that's our remainder. So the question is, well, how are we supposed to write our answer? Right? Well, to answer that, look at how this thing is written. It's written as dividend over divisor. So if you look at our division algorithm, how could we make the left-hand side look like dividend over divisor? Well, you just divide everything by the divisor. The divisor cancels here, so we're left with this, quotient plus remainder over divisor. That's how we want to be writing the answer to these division problems. So, okay, I'll just write this as quotient, which is 2x squared plus 3x minus 2, plus remainder, which is 1, divided by the divisor, and that's the answer. So I know that was kind of a lot to talk through, but it's actually, once you get the hang of how this works, it's just the same thing over and over. So let's do an example of this. All right, example number 1. We have a quartic function divided by a quadratic function. The thing that I want to draw your attention to with the quartic function in the numerator is if you look at the powers of x, they go from 4 to 3, but then the x squared term is missing before it goes to 1. Now, one thing that I think is going to be important to get into the habit of doing is making sure that all of the terms are actually present. In the case of long division, all that's really going to do for us is make sure that things are aligned properly. So when we're doing the subtraction, we don't have to, look for like terms. They're just going to be right on top of one another. But later on, not putting in this 0 placeholder, which is what I would do to fix it, becomes a much bigger issue. So it's good to get into the habit of doing it now so that when we learn another method in another video for division, we don't get tripped up by this. You should also look in the denominator as well, but that one looks fine. We go from 2 to 1 and then to 0. Once you get that 0 placeholder in, then you can rewrite it. All right, so how do you make 3x squared look like 6x to the 4th with multiplication? Well, it's with 2x squared. So then we're going to take that part of the quotient that we just found, multiply it by our entire divisor, 2x squared times 3x, so this right here gives us 6x to the 4th. 2x squared times negative x is going to give us negative 2x cubed, and then 2x squared times 6 is going to give us 12x squared. So we get this here. By the way, those first terms are always going to cancel. We made them the same on purpose. So this canceling is by design. That's always going to happen. Next, you have to do 7 minus negative 2. That's going to be positive 9x cubed there. And then 0 minus 12x squared is going to be minus 12x squared. Then you can bring down the 10 to get this. Another thing to mention that I don't think I mentioned earlier, the reason we always bring down something, you want the length of the thing that you're looking at to be at least the length of the polynomial you're dividing by, to be at least the length of the divisor. That's why in the first one that we did, which was a binomial, that was our divisor, we were always looking at 2 things at a time here. But here we need to be looking at 3 things at a time since our polynomial is larger. Or longer, I guess I should say. Now I just wanted to show you guys what would happen if you didn't put in that 0. You'd end up with the exact same thing that we just did. Everything's the same until you get to here. These are going to cancel. Then you're going to do 7x cubed minus negative 2x cubed. That's going to be 9x cubed. And then what you might do is you might do 10 minus 12x squared there to get yourself negative 2x squared. Right? I mean, you just did something over itself when subtraction, something over itself did the subtraction. So it might be, you get to this third one and you're just in automatic mode. But those aren't like terms. right? You would have to cognize that, well, wait, no, the 12x squared goes first, and then the 10x comes after that because those aren't like terms. And then now we don't really have to bring anything down like we did here because, you got your three terms. So that's why I always just have students write in the zero placeholder, because it can be confusing when you don't have terms aligned. And even if it's not confusing, I guess the main point is like a lot of this stuff is just like you're on automatic, right? And if you're on automatic, it can be very easy to make a mistake like that. All right, next we have to make 3x squared look like 9x cubed, and you can do that with 3x. So again, you take that part of the quotient that you just found, you multiply it by your entire divisor. I'll just go through it again. 3x times 3x squared, that's how I got the 9x cubed. 3x times negative x, that's how we got the negative 3x squared. And then 3x times 6, that's how we got the 18x there. And then we just do the subtraction. These cancel. Negative 12x squared minus negative 3x squared is negative 12 plus 3, so we get 9x squared. And then 10x minus 18x, that's negative 8x, and I brought down the minus 1. Finally, we have to make 3x squared look like negative 9x squared, and you can do that with negative 3. So again, you multiply that part of the quotient that you just found, which is really negative 3. I should have done this, multiplied by all of these things. But if you do that distribution, you get this. Negative 9x squared plus 3x minus 18. The first terms cancel. Negative 8 minus 3 is more subtraction, so you get negative 11x there. And then negative 1 minus negative 18 is actually an addition of 18, so you get plus 17, and that is your remainder. Okay, so then we'd write it as quotient plus remainder over divisor. But if you wanted to, since this is a negative sign, you could replace this with a minus. You just have to make sure that you change those signs right there so that it would become this. But either way you want to go there, I think is fine. All right, example number 2. What I want you to do is I want you to pause this and give this one a shot. This one is, it's a lot. We're only dividing by a binomial, although there is something that you should try to notice about the denominator before you write this thing out. But go ahead and pause the video and give this a shot. All right, welcome back. Here's what I did. This is probably a lot to take in just by looking at it. I don't really want to explain the whole thing, but to make 2x squared look like 10x to the fourth, I had to multiply by 5x squared. After I did the subtraction, I needed to make 2x squared look like negative 4x cubed. So I did that with minus 2x. And then after the subtraction, I needed to make negative 8x squared from 2x squared, so I multiplied by negative 4. So that was my quotient. And actually, my remainder ended up being 0. So technically here I have 0 over 2x squared minus 7. But because it's 0, I don't actually need it. Which means that we technically factored the numerator, right? We just showed that because it was perfectly divisible by 2x squared minus 7, because we got 0 as the remainder. When you write it using the division algorithm, which is divisor times quotient plus remainder, you just have this. So we've kind of partially factored this quartic function. And, if we wanted to, we could figure out where these intersect the x-axis, and we can even factor more than that. Just a little preview for where we're headed with this division stuff. But anyway, that's it. Thanks for sticking with it. Hopefully you guys learned something. If you guys have any questions, please leave a comment below or send me an email. Thanks a ton for watching, and I'll see you in the next one.